Hi folks, this is part number 2 for talking about the sun. We left it off last time talking about the active regions, particularly the connection between the photosphere, the coronosphere, chemosphere, and the corona. And now we're going to be talking about the connection of all these little things that we're calling flanges and sunspots and things like that, and how we know what we know. So the basic cause of all this activity we understand is from magnetic fields. Now I haven't shown you the data for that yet, but that will come in the next chart. But remember that magnetic fields will cause electronic charges to move around these field lines in tight concentric circles, and they'll just follow along here. And they will basically, if we have a solar wind coming off of this thing like we do, heat gases are going to be expelled from the surface. These electric charges, they're not really gases, it's really a plasma. And the plasma is just positive and negative charges. They're going to get tied up in all these field lines and become more and more dense. All right, so electrons and positrons move in these magnetic field lines. They cause a 11-year cycle from solar maximum to solar minimum. And over the years, we've been observing this sort of behavior for a very long time. This region is called the outer minimum, and I'm not exactly sure what has caused it. But since that time, we've observed variations, but the peaks and the valleys are separated by 11 years. And I'd imagine these regions here where we have data taken, sort of like people like Galileo and Kepler, sort of one-offs, every once in a while they'll take some measurements and they observe stuff. But here it looks like, people were actually measuring these things day in and day out. And that has occurred, ever since. Another way to plot sunspots is to not only locate where they are as far as time is concerned, but also where they are relative to where they occur on the sun. So basically you see in this chart here that in the northern regions, the middle and high latitudes, both positive values and negative values, we don't see a lot of sunspots. We see them around the equator though, but not precisely on the equator. It seems as though there's a minimum value at the equator as well. Well, how do we know that these are associated with magnetic fields? Well, there is an effect called the Zeeman effect, and if I look at a spectral distribution from any element and I stick it in a magnetic field, then the line will split apart. In this particular case, we're looking at an iron splitting, where it goes from one line to 3, but this need not be the case. Different elements will split in different ways. So this just happens to be an iron spectrum that we're looking at, an iron absorption line. And what we notice here is that we get 3 absorption lines associated with this the sunspot. And if we look at a different sunspot, we're going to get something similar, but positive and negative show up in different ways. So the basic thinking is this. The sunspot has magnetic field lines coming out of it of a certain polarity. They go up into the atmosphere and they come back down into another pole region, another sunspot, and it goes back into the interior of the sun. These magnetic field lines, they have a detrimental effect, if you will, upon the convective loops in the sun. So the region where we have the sunspot cools off because convection does not occur in this region. So if convection doesn't occur here, then this region will cool off. heat isn't being replaced down from below, and heat is escaping from the top surface. So the thing cools off. Kind of interesting how it works that way. Now, there is a correlation between solar luminosity and sunspot number, but it is not a big one, though. As you see here, it's 1 part in 1,000. But it is there. So if you hear people talking about global warming and talking about solar luminosity and sunspot number, I would suggest not believing them. Our impact on global warming is much more severe than that. All right, this is the current theory for where these magnetic field lines are coming from. Remember that the key thing here, and remember this, that the rotation of the material on the surface of the sun along the equator is much faster than that in the poles. So if I have a magnetic field line caused because of the plasma, remember we have positive and negative charges sort of floating around, nothing is electrically neutral, then these field lines are going to be caused by the motion of these particles, these charged particles, and the magnetic field line is going to be pulled along the equator faster than it is in the North Pole or the South Pole. This will have an effect of twisting up the magnetic field lines and cramming more material into these regions of the atmosphere, getting them hotter and hotter and hotter until at some point they will just blow apart and we have a coronal mass ejection. Remember, as it says down here, the plasma is married to the field line. The charges, those electrons and positrons, electrons and protons are tied to those magnetic field lines. This type of theorization and measurements are continuing all the time. This is from Physics Today, not too long ago, volume 66, and they talk about theory talking about in the corona magnetic reconnection in 2 dimensions associated with some of these field lines. So the point being is that this is ongoing. When I first started teaching astronomy again, 5 years ago, the thought was that nobody understood why the corona was so hot, 10 million degrees Kelvin. Nobody understood that. But I think the understanding now is that we have a good idea of what's going on. The idea is that these field lines are capturing the electrons and the protons of the solar wind that are coming out of here, getting tied up here. So if you could imagine these field lines, one coming from one sunspot, the other coming down here, imagine that you have a slinky and you're constantly twisting it and twisting it and twisting it and twisting it and twisting it some more. At some point, this slinky is going to break apart because there's no more strength left into the wire metal there. And once it breaks, the whole slinky unravels. And if you can further imagine that you have a bunch of things that are collected on these bits of wire of the slinky, and when it flies apart, what are those particles going to do? Well, they're going to fly away. So I think that's sort of a view to, a simile, an analogy for what we think is going on. Okay, thank you very much.